The land of Ohio features hundreds of different types of soil. It helps us grow a wide array of products. Underneath the fields and forests, however, lies a different type of story. The geologic story of the state. A story of rock, water, ice and mineral wealth that scientists with the Ohio Geological Survey love to tell and are actively preserving. To unearth it, you don't have to dig, but you do need to get beyond the bustle of Columbus and head north to the more natural setting of Alum Creek State Park in Delaware County. There lies the Horace R. Collins Repository and Lab, where geologists and seismologists study the ground below us and serve as the caretakers of a number of collections.
We're not a museum here by any means. The thing I like to tell people is that we're basically a library of rock.
The site houses sediment and rock samples, fossils, maps and photos, along with 600,000 feet of rock core drilled and collected from nearly every corner of Ohio. The lab, which opened in 1999, is named after former state geologist Horace Buzz Collins, who led and expanded the survey for 20 years. These stones serve as a physical record, stretching from the surface down to the pre-Cambrian basement, or through about 1.5 billion years worth of deposits.
In terms of Ohio, I think what a lot of people don't realize is the range of geologic history that we have here. You have evidence of volcanoes, if you dig very deeply. We have evidence of meteorite impact. Looking at this, I'm seeing a whole lot of rock fragments that are just broken up and busted up and just kind of cemented in a very chaotic fashion. So some kind of violent impact on the land surface left its mark there. Of course, we have had a number of glaciations across the state that have hugely impacted the way the surface looks today.
Those glaciers were a big deal, shaping the hills, valleys, and flat regions of 2/3 of Ohio. They left behind rich mineral and soil deposits, wetlands, and even helped create Lake Erie.
And I think it's things like that. It's that diversity of geological environments and that broad span of time that makes Ohio so interesting.
The full history of Ohio's formation is a bit too long for our visit today, but for researchers with know-how, this lab provides stone portraits of the past that they can read like any book.
It's telling the history of the rock, what the rock has been through, how the rock was deposited, and what changes the rock has undergone ever since it was deposited.
By examining patterns, minerals, or chemicals in the banded layers of these stones, specialists can walk back through time to answer questions. Was a layer formed during a period of serene life, or one of violent transformation?
Here's an excellent example. Here's a portion of the rock where the color changes a little bit, and we have a little bit of a separation here. So I might want to look at that more closely and figure out why is that? Why has that color changed? It depends on what your area of interest is and what you're looking for. You might be looking for microfossils. You might be looking for chemical traces, for example, carbon. You might be looking for radioactive signatures, for example, gamma.
Shale gives off more trace gamma than other sedimentary rocks, which leads us to why most folks might stop by to see a sample here: the possibility of industrial minerals.
The whole reason we had a geological survey in the first place was we were a young state and we needed to know what the resources were and where they were. And one of the things that we do here is we make our information available to industry so that the resources can be developed.
In Ohio, those major resources include many of the usual suspects: energy minerals like coal, gas, and oil, and industrial minerals like salt, or dolomite and limestone, sand, gravel, and gypsum used in construction. Clay and shale are used in ceramics, and flint, our official state gemstone.
I would say there's probably no one mineral that you could find everywhere in the state. And that's just because, the state is diverse geologically. We have 2 large mines underneath Lake Erie that are devoted to bringing out rock salt. And we also have other mines in the state. The majority of the limestone and the dolomite that have any economic value, those tend to be distributed on the western half of the state. Coal that has any economic value, that's going to be in the southeastern portion.
The state's history with oil, gas, and coal is well documented. In the 19th century, Ohio was once the leading producer of oil in the world and the birthplace of Standard Oil. The boom has slowed down since then, but technology has allowed the industry to diversify into areas like hydraulic fracturing or fracking alongside the mainstays, keeping Ohio strong in the energy business.
Something else that's important is carbon sequestration. It has been proposed that CO2 can be disposed of effectively by injecting it into the rocks. And so that's something that we've been involved in researching or providing assistance to others.
Along with exploration, conservation is another main part of the survey's mission.
The taking of coal, for example, or the taking of rock salt. We make sure that those activities don't harm, for example, the groundwater. We try to balance these opposite interests, the interest of economic development on the one hand, and protection of the resources and protection of the environment on the other hand.
In addition, they use their data to develop land and groundwater, mitigate hazards like abandoned mines, or formations that might cause landslides or flooding. Another major event to keep track of: earthquakes.
There are more smaller magnitude earthquakes than there are larger magnitude earthquakes. So what we do is we listen for them with better instruments, and that kind of reveals something about what's going on below Ohio and the ground, not just in the places that are used to having earthquakes.
Jeff Fox and his Ohio seismic team at the HRC station have a number of seismometers here recording quake activity along with USGS and other equipment. In addition, they coordinate nearly 30 other sites around the state.
When an earthquake occurs from that point source on the fault, you get a primary or P wave. That's the one that arrives at the seismometer first and indicates that there's an earthquake or some other kind of energy source underground. It's a compressive wave. It's a sound wave, basically. It travels through the rock and compresses the rock in front of it in the same direction that it moves. And after that, you get an S wave, or the secondary shear wave, which is a side-to-side shaking movement.
Since they know the speed of the P wave, if they can sense the quake at 3 different stations, then they can use the S wave speed and a bit of software to triangulate the location of the fault. The largest quake on record was a 5.4 magnitude trembler back in 1937, which caused some structural damage in the town of Anna. Clearly, we don't see many big quakes here, but there are a handful of small ones each year.
The leading cause of most of the earthquakes, especially in the northeast part of the state, is you got tectonic stress that's everywhere built into the Earth's crust, basically from the spreading of the mid-Atlantic ridge. So the entire eastern portion of the U.S. continent is slowly moving to the west.
And as far as the notion of oil and gas exploration causing more quakes, Jeff says the jury is still out because the science is still unclear.
There have been some published papers recently that have talked about fracking-related earthquakes in Ohio. It's nowhere near the level that they're experiencing in Oklahoma, but then that's kind of part of the mystery. Oklahoma's experienced a lot, but they've had a lot more activity out there. Then you got places like North Dakota that have had just as much activity, oil and gas exploration, but they've had literally no earthquakes. So that's kind of the big question. It's why that occurs in one place, but it doesn't occur in another.
It means his team and others around the country will have to continue to monitor and map activity until more is known. It's those and many other unanswered questions that keep the scientists hard at work here at the HRC.
I know they say Ohio's not, as seismically active as some of the other states, but I think that might be part of the draw, as we don't know what's below the ground here.
And even this stuff, we have hundreds of feet of rock salt. And how did that form? There's really no place on the Earth today where that kind of formation is taking place. So it's sort of a mystery. There's always new things to discover, and we live on the Earth. So everything that we touch in one form or another came from the Earth. It was either mined from the Earth or it was grown from the Earth. So agriculture, engineering, just about anything you can think of is really tied in some way to geology.
And that's true, whether we're looking at the past or building the future.